All right, thanks everybody for coming out here today. So we are three researchers from Lookout Mobile Security. We like to do a lot of nerdy things on cell phones and poke around with them. So we're going to be talking on Android permissions today and some of the fun things that we can do with and without them. So the things we're going to talk about today, we're going to do a brief, boring overview of the Android internals, just to get people who don't have any context of what some of these components are up to speed a little bit. Then we're going to talk about the security and permission model and a little brief overview on that and how the sandboxing works. At that point, then we'll talk about some of the fun things that we can do with permissions and without permissions, and then talk about how we can use the system logging to leverage a lot of stuff as well. And then we're going to talk a little bit about rooting Android phones and some of the fun things with that. And then, of course, mitigation and what we can do to kind of approach these problems. So first thing, Android internals. So the Android manifest is basically just a big XML file that every application needs to every Android application needs to have. The manifest is going to define your package name, which is a unique identifier for every application that's going to be in the market, and this is going to be your com.android.whatever. That's your package name that you usually see. Also, it's going to describe all the various components within the application itself. Any receivers, broadcast receivers it's going to have, activities that it has, any services, that kind of stuff. Also, this will declare all the permissions, both permissions that your application needs to access a lot of the protected APIs, and also permissions that your application requires for other applications to interact with its components. Activities are basically just UI screens for Android, a way for the user to interact with the application. The activities themselves are just composed of a bunch of UI widgets called views, which are your button views, text views, that kind of stuff. The activities themselves are managed in what's called an activity stack, basically meaning that any new activity created is going to be at the top of that stack on the screen, and any other UI screens are going to be down below that on the stack. The most foreground activity is going to be the running activity in an active state, and any activities down below it on the stack are going to be in a pause state where they're not running, not doing anything, and just saving state. The activities will remain in that stack until they finish, or the system can yank them out and kill them if memory is running low. Applications can also start other applications' activities remotely. The activity itself is going to run within the process of the remote application. So in a situation where you've requested location permissions and you want to have the user turn on their GPS and you detect that that's not enabled, you can start the settings activity with all the location settings so that they can enable that, and then once that activity finishes, they'll be back at the previous screen. Since that's running in the remote, it's running in its own applications process, the callee won't necessarily have access to any of the data in that activity. If you're starting your own activities within your own application, then you'll of course be able to have access to that. Activities themselves can have permissions enforced on them so that other processes can't start activities within your application without having requested whatever permission that you set. Intents for Android are basically a way for applications to do simple IPC so that they can send an event or an action along with data, which is usually in the form of a URI. So if we want to start up a browser, we can send an action view intent with a URL as our data, and that will fire up the browser using that intent. Okay, as you said, they can be started, or they can be used to start activities with start activity. We can also broadcast intents using send broadcast, and this basically just sends out an intent en masse. So for instance, anyone that would want to be notified about an SMS being received, an intent will be fired off across the system to anyone that wants to know about that event. There will be two types of intents that you can receive that way. There are just normal regular intents, which are just sent out en masse, no particular order, all at once. And you can't actually abort those intents or use the result from those. And then you also have, I'm not even on the right slide for that. So yes, the normal, and then you also have ordered broadcasts, which are, okay, I'm sorry, I'm mixing this up. Okay, so those are the intents. You can use those to communicate those. And then the broadcast receivers are what are going to be receiving those. And that's what I was talking about with the intents firing in a broadcast way. So we can do an ordered broadcast, which is sending them out sequentially to each of the different receivers, where when one receives it, it'll get the result from the previous one, be able to do whatever kind of processing it wants on that. It can also abort the intent if it wants to, or abort the broadcast so that no one else further down the line will be able to receive that, and then they can also send their result to the next receiver down the line. We can declare our broadcast receivers in two different ways. We can either register them dynamically within our application, or we can have a static receiver tag within our manifest. Also, our broadcast receivers can also have permissions enforced on them, so that you can either request that you need to have a certain permission if you want to send something to me, or that if you're sending out a broadcast, only broadcast receivers that have requested this permission can receive that. Services are a component that sound just like what they are. They do work in the background. They aren't actually a separate process or running in a separate thread. Any processing is going to run in the main thread of the application. So if you're going to do any kind of CPU-intensive work or blocking, you're going to want to spin off your own thread from your service. But this essentially just acts like an activity without any UI for it. And like all the other components, these can also enforce permissions for access to them. With the security and permission model, so we all know that Android is all the processes are running in a sandbox, and everyone's aware about the security around that. The sandbox itself is not the VM. A lot of people think that the Dalvik VM is the sandbox. This is not the case. The sandbox is actually just Unix user permissions that Linux uses and all that kind of stuff. Basically that you have your UID and GID for every process, and every application is essentially a different user on the system, so they don't have access to each other's data on the file system, and then they're also just running in a multi-process environment where they're going to have segregated address spaces. Each process running, or each application running, is going to have its own lightweight VM, which is the Dalvik VM, which is just a Java-like VM that is based off of passing through registers rather than on the stack. And if you're able to break out of this VM, you gain nothing. If you're able to get native code execution, you're still going to be running in the same process with the same user privilege that the VM itself had. Applications can both request to share a UID, so that they're essentially both running as the same user, and then they can share data on the file system and some other things. Both applications need to request that explicitly, and both applications would need to be signed with the same signer key. Permissioning is essentially just a more fine-grained enforcement of access to various protected APIs on the system or content. So any application that wants to be able to access the internet or receive SMS or look at your contacts, they're going to have to request specific permissions to be able to do that. And these are, as I said, declared in the manifest. So with that, David's going to talk about some of the fun things that we can do with these.
Thanks, Anthony. So now I want to talk about a little bit of Android development and why permissions are important, why you ask for them in the first place, and do we need to ask for them? So the motto here: why ask for permission when you can ask for forgiveness? So the reason why permissions matter is because they gate what an app can do, and the user is displayed them when they install an application. So you install Pandora Radio from the Android market. You see this screen here that tells you different things it can do. It can access the network, so that seems appropriate. It's Pandora. It's internet radio. It should be able to. It can read your phone state. That's presumably to pause playing of the radio when you get a phone call. So users can look at a screen like this, and they can decipher to some degree whether or not those are appropriate permissions for the application. So let's go to another example. Here are two different tic-tac-toe apps. One of them only requests internet and to be able to view the network state. So maybe it has a high score, maybe it has multiplayer. But this other one requests system tools, mount and unmount file systems, which just sounds strange. So if I were you, I would download the one that only accesses the internet. And so what does it mean if you request 0 permissions? That means when you click install from the market, it just starts downloading the app. There's no warnings. It doesn't warn you at all about what an app can or can't do. And so I think that a lot of users will probably assume if they don't see that screen that they shouldn't worry about that app. That app can't do anything harmful to me because it's not requesting any permissions. The OS isn't warning me at all. So we're going to show all sorts of fun things you can do with 0 permissions. So some of these are silly, and some of them have more serious ramifications. So the first one is reboot. There's a reboot permission that's actually marked as signature or system, and what that means is that it's not actually grantable to apps from the marketplace. This permission would be denied if you requested it. You have to either be signed by the device signer or be in the system directory in order for you to be able to be granted this permission. You could say that Bob the Guardian is protecting this permission. A reboot joke fell flat on this audience? All right, thank you. But Bob isn't going to stop us. So there are a couple different approaches to do this. The easiest one involves toast notifications. So here, a toast notification is a way to notify you of something that goes on in the background. So in this case, you're in the keypad activity, and a toast pops up to tell you about something else that's going on in the OS that some other app is doing. So here's just the basic hello world for a toast, and then I've thrown it inside a while true loop. So we're just going to create as many toasts as we can and see what happens. Every time that you create and display a toast, it creates a weak JNI reference in the Android system server. And when you get to 2001 global references, the system says, "I can't let you do that, Dave," and throws a SIG-SEGV and crashes the phone. So that's cool. You can get the OS to reboot. That's pretty fun. But during this process, it would display a little toast on the screen that would say something like "Hello World." Now you could do something fun with this, like display a countdown timer to when your phone was going to reboot. But you could also maybe we can make this even more hidden. So there's also this idea of a custom toast. So a custom toast is any view I can display on the screen. So here, this custom toast is Powdered Toast Man. Just an image of Powdered Toast Man appears, fades in, would fade out. But you could also just create a view with nothing in it. So you just create an invisible view, you pop it up, and after about 20 seconds of this loop running, the phone reboots. So that's one cool thing that we can do, that any app can do, because this requires 0 permissions. So, without any warning, an app could reboot your phone if they wanted to. So now that your phone is rebooting, and it starts to boot up, there's a permission called Receive Boot Complete. And this shows up in the Android permission screen. It says, allow app to start at startup. Or something along those lines. But the idea here is is that the app would automatically start, right? So this one,